This video is for week 1 of the physics summer school. This is about mechanics. In the first question, 8.6, you'll be using the equation speed equals distance over time. Please bear in mind that s is the distance, not the speed. V is the speed. And remember that if you want a speed in meters per second, your time has to be in seconds. Question 9.6 is about the difference between displacement and distance. The distance you calculate in the same way as you did for the previous question. Now, to find the number of times that someone has gone round in a circle on a circular path, you need to know the total distance they've travelled and divide that by the circumference of the circle. And if you are asked to calculate the displacement, drawing a quick sketch should help you identify what the length is of the straight line connecting the point where the person started and the point where the person ended. When you draw the diagram, hopefully the geometry will make that calculation easy. Question 10.3 shows a displacement time graph, and you're asked to deduce speeds and velocities from that graph. Remember, the speed is the magnitude of the gradient of a displacement time graph, and the velocity is the gradient. If the gradient is negative, the velocity is negative. The speed will just be a number, won't have any negative sign attached to it. Question 11.10 asks you to calculate acceleration, which is the difference in velocity divided by the time it takes for the velocity to change. The difference in velocity is always the final velocity, v, minus the initial velocity, u. If you have a velocity in miles per hour, you can convert it into meters per second by multiplying by 0.45. Question 12.3 will have you analysing a speed-time graph. Remember that the gradient of the line on a speed-time graph is the acceleration, and the area between the line and the x-axis is the distance. If you have a graph such as this, where we have a straight line, then you can break it into shapes. Calculate the area of each of those shapes and then add them together. The area of a triangle is half base times height, and the area of a rectangle is just base times height. Read the values of the y-axis and x-axis to find what the height and the width of these shapes are. Question 13.1 will have you examine resultant forces and equilibrium. To find the resultant force, you add up the forces that are presented to you. In the example I've drawn here, there is a red force to the right and a blue force to the left. If we choose the right-hand direction as positive, then by adding these two forces, you subtract the length of the blue force arrow. And the resultant force would be from the start of the red arrow to the end of the blue arrow. That would be the green arrow drawn here. If the forces are in the same direction, you can just add them together. And if they're at 90 degrees to each other, you'll have to use Pythagoras to find the resultant force. Remember that forces can be drawn anywhere. They don't have to be drawn on the body for the diagram to be correct, as long as the arrow is the right length and in the right direction. So a diagram like this can be redrawn. By drawing the start of one arrow on the end of the other, it's now possible to find the resultant force, which goes from the start of the first arrow to the end of the last arrow. This is a right-angled triangle, which is why Pythagoras can be used. If you wanted to know the magnitude of the force that would balance this, it would be the same magnitude as the resultant force, but in exactly the opposite direction. That's because if the forces are balanced, then the shape forms a closed triangle. And if I draw that final shape back in, you can see that this forms a closed triangle. And the length of this green arrow is the same as the length of the resultant force arrow, but it's in exactly the opposite direction. Question 14.7 is about resistive forces, but actually it's about factor changes. If your factor change is proportional, then doubling B will double A. However, if we do not have two variables that are proportional, for example, A varies as the square of B, then doubling B will more than double A. In fact, it will increase it by 4-fold, and tripling B will increase A 9-fold, because you are squaring that change. If I changed A and wanted to see what the effect would be on B, you'd square root that change. So the square root of 2 is 1.4-ish, so doubling A would only increase B by a factor of 1.4-ish. quite a tricky sheet, that one, the 14.7 question, but do have a go at it and do use the hints. Question 16.7 is about the principle of moments. That is that in equilibrium, the total clockwise moment will equal the total anti-clockwise moment. It should be a straightforward case of plugging numbers into this equation, but do watch out for tricky situations, for example, where forces are on the same side of the pivot but are in opposite directions. Make sure you're aware whether a force is producing clockwise moment or anti-clockwise moment. 19.8 is about Newton's second law, and that is that the force exerted on a body is equal to its rate of change of momentum, where momentum is mass times velocity. A change in momentum is a change in mass times velocity. And if the mass of a body doesn't change, then the change in momentum is the mass multiplied by the change in velocity. Sometimes Newton's second law is more easily recognised as F equals ma for this reason. Just be careful in questions where it doesn't seem to give you all of the information. For example, if the context of the question says that one of the bodies stops, you are given the final speed as 0, although it doesn't explicitly state that. Question 20.9 is again about Newton's second law, but this time it is the mass that is changing. So just be careful when you read the question. Now, I've chosen some very challenging questions here, and it could take you an hour, even more than an hour, to answer them. I've chosen some of the trickier questions from each of the boards, with a couple of more straightforward ones along the way, just to give you some confidence. I mean, there's no way in a video that's under 10 minutes long I could have covered what would take you an entire term, maybe even half a term if you rush through it, in a classroom. So there are hints online to help you. First of all, make sure you are logged on to Isaac Physics before you attempt the questions, or your progress will not be recorded. And then you'll see the board of questions. When you click on a question, there are hints at the top. If you click hints and click the link, it will take you to a page that will explain to you some of the physics. There is also, on a lot of these questions, a video that you can follow along that may give you a bit more guidance without giving you the answer. And those are on each of these questions. If you enter an answer wrongly, sometimes it will even tell you why your answer was wrong. Some of this is going to be independent learning. Unless you've already mastered all of this topic, this is going to be a tricky topic for us to start off with. So make sure you do send me your questions through so that we can discuss them on Saturday's tuition session.